scientists, and welcome to my video on EM waves for GCSE. EM stands for electromagnetic, and I'm going to be going through each of the types of waves today, some of their uses, and then for higher tier only I'm going to be talking to you about how we can use radio waves and electrical circuits together. Now, remember that if you want the notes on this topic, to check out my resources on the My EdSpace website, and if you want to have a look at joining my live lessons, check out the link in the description of this video. So, let's jump straight in. Now, as I said earlier, EM waves stand for electromagnetic. Now, at GCSE, don't worry too much about what that means. That's just what they stand for. You'll learn about why we call these guys the electromagnetic waves at A level. But there are 7 waves in my spectrum. We start at radio waves that have got the longest wavelength, all the way down to gamma, which has got the shortest wavelength. Now you might be thinking, gamma, we've met that one before. You're absolutely right, we have. We met gamma radiation when we talked about our radioactivity topic, and it's actually the same gamma, okay? So this part of the electromagnetic spectrum, these really tiny wavelengths of gamma radiation, they originate from unstable nuclei, okay? So it's exactly the same kind of gamma that we've met before. Now, you need to know some of the uses of the electromagnetic waves for your GCSE. So let's start with radio waves. Now we use radio waves, as the name would suggest, for radio, but also for transmitting TV signals, okay? Now, at a slightly lower wavelength, slightly smaller wavelength, are my microwaves. We use these guys for satellite communications, but we also use microwaves, remember, for cooking food. I'm sure you've all got microwaves in your kitchens, and they produce this type of electromagnetic wave. They produce microwaves. What microwaves can do is they can cause the water molecules in your food to start oscillating, okay? Makes them start moving. Now we know that when particles get warmer, they start to vibrate more. So the microwaves basically warm up the water molecules in your food, and that's how it cooks your food. This is why there's some things that you have to do when you put them in the microwave. You need to add water to them first before you can put them in the microwave. This is also why you need to make sure that you stir your food when it comes out the microwave, because the microwaves will only heat up the water molecules. It won't necessarily heat up the whole of the food. Right, next up we've got infrared. Now, infrared radiation is the type of radiation given off by hot objects. I'm going to teach you more about infrared radiation in a later video. So all we need to know for the uses is we use it for heaters and in infrared cameras. So infrared cameras allow us to detect infrared radiation coming off hot objects when we can't see them using visible light. So for example, wildlife cameras, when it's dark, so you can't see the animals, we can use the infrared radiation they're giving off, because animals will be hot, to detect where they are. Right. Visible light. So this is the part of the electromagnetic spectrum that our eyes can sense, and this is why we call it visible light, okay? So our main use for visible light is fibre optics, which is when we send information down these flexible tubes using light. Some of you might be watching me right now on fibre optic internet, which is where we're sending all that information from the internet into your house using light going down these small flexible tubes. Right, ultraviolet. 2 uses of ultraviolet. We use them in energy efficient light bulbs. Again, you cover that in more detail at A level. We also use ultraviolet for tanning, but we're going to get onto that in just a minute. And then finally, my X-rays and my gamma rays, we use them both for medical imaging and treatments. I'm sure that some of you have had X-rays before to look at bones, things like that. So what happens is that the X-rays will pass through the skin and the muscle and stuff like that. They'll be absorbed by the bones. If you put this on what is essentially a piece of photographic film, so your arm goes on there, X-rays go through. The photographic film develops where the X-rays hit it, won't develop where the X-rays didn't. So, for example, where the bone in my arm would be, and that's how we can get this imaging of the inside of our bodies. Gamma radiation, we talked about how we can use that as a medical tracer in our radioactivity topic. Now, these three down here, ultraviolet, X-rays and gamma rays, have got the lowest wavelength. So that means that they are the highest energy. And they are, in fact, all three of them, they are ionizing, okay? Now, you might remember that word from our radioactivity topic as well. Ionizing radiation is when radiation can knock electrons off the outside of atoms. For just one or two atoms, like in the air, not going to be so much of an issue. If it's ionizing atoms inside your DNA, that can change how your DNA is bonding, that can change the structure of your DNA, it can cause mutations, and they can even lead to cancer. So, our main risks with ultraviolet, because actually it's the lowest energy of the higher energy ones, it's like the least ionizing, the main risk with ultraviolet is actually going to be skin cancer. Okay, because actually it's unlikely to cause much more damage, more further inside the body. This is why when we say that the use for ultraviolet is tanning, yes it is, but that's also going to increase your risk of skin cancer, or it could even increase your risk of cataracts, which are a thing that happens to the lens of your eye. It kind of goes like cloudy because of exposure to UV radiation. So we have to be quite careful when talking about using ultraviolet for tanning. Now, for X-rays and gamma rays, my biggest problem here is going to be they can cause cell mutations, which can lead to all sorts of different types of cancer. So we need to be careful when talking about using ultraviolet, X-rays and gamma rays. If we're ever going to use them for medical uses, things like that, we always need to make sure that what we're using them for is an appropriate reasoning. Okay, this is what you need to know on the uses of the electromagnetic waves. Next up, I'm going to talk to you about radio waves and electrical circuits. You need it if you're higher, you don't need it if you're foundation. So, stay tuned.